After reading through this word problem, I think cost is actually implying that this is how much they're selling these cookies for. So if you've already paused the video and read through, think of that as the selling price, and this is the selling price. The final sentence usually gives it away in a word problem. How many of each type of treat should be made to maximize the revenue? So we want to maximize how much we make, so we're trying to maximize this function. It's a function of two variables of x, which we can let represent the cost of each, how much we sell each package of cookies for. And it's a function of y, how much we can sell each cupcakes for. So we want to maximize this function. So it's like a linear optimization problem. So going on to the next sentence, the time required to make cookies is 2 hours, while the time required to make cupcakes is 3 hours. And there's only 400 hours of labor available. So 2 times the number of cookies that we package tells us how many hours it's going to take total for the cookies. Plus 3 times the number of cupcakes that we package tells us the amount of hours for that. This quantity needs to be less than or equal to 400 hours, because we said there's only 400 hours available. So we've taken care of all this information so far. And this piece says management has decided at least 20 sets of cookies should be made, and at least 30 sets of cupcakes should be made. So they said cookies needs to be at least 20, and cupcakes needs to be at least 30. So we have to abide by those constraints as well. And then the last part is the part we've already read. How many of each type should we maximize? So we're going to graph these 3 inequalities. And after we graph them, we'll find the vertices and plug those into the function that we're trying to maximize. Let's graph this first one in red here, this one right here. 2x plus 3y equals 400. This kind of looks like standard form of a linear equation. You can use the cover-up method to find out the x and y intercepts. If you plug in a 0 for y, or if you cover up the 3y, in other words, you're left with 2x equals 400. So to find out where it's going to cross the x-axis, you just divide both sides by 2. So at 200, we're going to put a dot on the x-axis. Then we'll do the same for the y-intercept. To find out where this red line is going to cross the y-axis, we'll put in a 0 for x, effectively covering it up, because 2 times 0 is 0. So we get 3y equals 400. In other words, y is approximately 133. So we can graph these other lines. X is greater than 20, which on our scale, if we're going by 50s, that's approximately this vertical line right here. Oh, I forgot to draw a red line, didn't I? I should do that too. We got 2 dots, we can draw a line between them. And then we got y is greater than or equal to 30. So we got to find out where y equals 30 and draw a line across there. So y equals 30, that's approximately right here. And I mean, they're not perfectly straight lines, but this can give us an idea of where the vertices are. Now we've graphed all 3 of the lines, so we've got 3 places of intersection. These are the places where we could potentially maximize our function: here, here, and here. So to find out exactly what the vertices are, you're trying to find out where the red line intersects the blue line. And the blue line represents the equation x equals 20. So if you plug x equals 20 into the red equation, that will tell you where they intersect. And I converted it to an equation because the equals equation, the equation of the line is where 2x plus 3y equals 400. So we're trying to find out where they intersect. So I plugged in 20 in for x because that is the equation of the blue line, where x equals 20. And now we can solve that like a normal equation. You got 40 plus 3y equals 400. Subtract that 40 from both sides. So you get 3y equals 360, or in other words, y is 120, because you divide both sides by 3. So we plugged in 20 in for x, found out y is 120, so that's this intersection point. So we got to find the other vertices. We got to find this one, and this is where x equals 20 intersects the line y equals 30. So that's already done for you. You're told the x-coordinate is 20, and the green line tells you that y equals 30. That's that intersection point right here. And then to find this one, this is where y equals 30, the equation of the line y equals 30. So we got to find out where that intersects this red line. So we'll do just what we did before. We'll plug in 30 in for y into the red function. Sorry, the red inequality. So simplifying from here, you got 3 times 30 makes 90. subtract 90 from both sides, you get 2x is 310. So you divide both sides by 2, you get that x is, 155. So we got the x coordinate now. At 155, this one's 155, 30. So now we have all three vertices, 20, 120, 20, 30, and 155, 30. We can find out the max. And we're going to use this function because this is the thing we're trying to maximize. We get $18 for the cookies. We get $22 for the cupcakes. So we'll plug all three of those vertices in and find out which one gives you the maximum amount. So we had three vertices. So I maximized just by plugging each in. So got this one on the top, 20, 120. That's 20 in for x, and then 120 in for y. So when you do that out, you should get 600. So 20, 120 gives us $600. Let's do 20, 30. And actually, you pretty much don't need to do this because you know that plugging in a 20 in here and a 30 in here is definitely going to be less. So this one, let's rule out. And then go 155, 30. Let's plug that into the function. So that's what it looks like when you plug it in. And then when you crunch those numbers out, you get 3,450. Wait a second. Yeah, I did something wrong over here. When you plug in 20, 120, this should not be 600. This top one should give you 3,000. So between the two, we got $3,000 and $3,450. So that means this bottom one's the winner. That means 155 cookies, because that was what our X was, and 30 things of cupcakes. That will maximize our revenue.